Hi everyone, this is 0624 IGCSE Physics, past paper questions from section 2, 1.2. It's dealing with kinematics. Okay, this is the syllabus. 1.2 deals with motion, where we define speed, velocity, acceleration, distance time graph, speed time graph, then free fall of an object with air resistance, without air resistance. Okay, these are the main subheadings under this topic. Okay, basically the formula for speed is distance over time. Its SI unit is meter per second. It is a scalar quantity. Speed is a scalar quantity because it has only magnitude, no direction. Velocity is change in displacement divided by time. The unit is the same. It is a vector quantity because velocity is speed with direction. Average speed. Average speed is the total distance traveled divided by the total time taken. Okay, and the SI unit is the same, meter per second. It is also a scalar quantity because it is speed. It's not velocity. Only magnitude is there, no direction. Acceleration is change in the velocity, like final velocity minus initial velocity divided by the time taken. And its unit is going to be meter per second square. Why meter per second square? Because you have your velocity on top and the time at the bottom. Already we have velocity meter per second, again divided by time. So you get meter per second square. Okay. And it is a vector quantity because it deals with velocity over time. A vector quantity divided by a scalar quantity gives a vector quantity. So it's a vector quantity. Then in that section, under the motion, we have the distance time graphs. Distance time graph. Okay, say for example, you take the first one. Here you have like two objects, A and B. They are moving with, this is constant speed. This is constant speed. Okay, wherever you see a straight line passing through the origin is constant speed. Here you can see, compare A and B. Look, A has reached 100 meter. Object A has reached 100 meter. This is 100 meter in like 2.5 seconds. If you see B, it has reached the same 100 meter in 5 seconds. So A has a higher steady speed and B has a lower steady speed. So wherever you see a straight line passing through the origin, in distance time graphs, it will be constant speed. Depending upon the steepness, it will be high or low. When you see a curved line in a distance time graph, it is accelerating. The object is accelerating. If you see like this, okay, either at some distance or even along the y-axis, along the x-axis also, like this. Again, it is for D and T, it is stopped. It is stopped. Here also it is stopped, or here. That means the object is staying after traveling 60 meter, it is staying in that, it is staying at that distance for 5 seconds, something like that. Okay, so that's what the curve shows. Okay. For a distance time graph, we have one feature, which is the gradient. The gradient of a distance time graph gives speed. Okay, you can check this calculation later. If you want, you can pause the video and check this calculation. The variation in delta y is 100 and the variation in x. So delta y by delta x is the gradient of this curve and it is going to give you the speed, okay, because it's distance divided by time, change in distance divided by change in time. That will give you the gradient, which is, that will give you the speed. For speed time graphs, we have, look, similar type of graph in distance time, it's going to be stopped. Okay, the object is not moving. But here it is steady speed. You can see from the graph, you can interpret from the graph like, the object for like 5 seconds, it is moving with the same speed, like 40 meter per second. So it is steady speed. We can call this as a zero acceleration graph too. Okay, now for the next one, here, in a distance time graph, when you see a line passing through the origin, straight line passing through the origin, it is uniform speed or steady speed. Here it is uniform acceleration, because change in speed divided by change in time is going to give you the acceleration. So it is uniform acceleration if it is a straight line. And when you see a curved section like here and here, there is a curved section, then it is non-uniform acceleration. Actually, here it decelerates. Here it decelerates, the object decelerates, okay? Here, in this one, the fourth one, you can see the object is moving from a speed of 20 meters per second to 0. So that means it is decelerating. Whenever you see a straight line, it is decelerating constantly. Okay, here again, steady deceleration. Steady deceleration. Okay. Now, under speed time graph, we have two features. One is a gradient, which gives you the acceleration. So gradient of a speed time graph gives you acceleration. The another feature is the area under the curve. The area under the curve gives you the distance traveled. So you find the area under the curve. No need to put meter square. You just put meter as the distance traveled by the object. Okay. And the last section of this unit motion deals with free fall of objects and free fall of, and objects falling with air resistance. Free fall of objects without air resistance and objects falling with air resistance. Okay, so when an object is not experiencing any air resistance, that means it is falling only under the gravity. This is a straight line, okay? Only due to gravity, it is falling. So that means we know the acceleration due to gravity is 9.8 meter per second square. So the object is having a constant acceleration because it is falling only due to gravity. No other external forces are acting. So in that case, you will get a straight line passing through the origin. But if there is air resistance, that straight line will be only for a few seconds. Then afterwards, actually the graph is like this. You would have seen this in your paper. So it's straight line for a few seconds, then it will curve like this, then it goes like this. Okay, then if it is a parachutist, okay, skydiver, so he will be experiencing constant acceleration only for a few seconds. After that, due to air resistance, he decelerates. Then he reaches terminal velocity. At this point, he opens the parachute. Once the parachute is open, due to the surface area, air resistance increases. So his acceleration decreases because the net force decreases drastically. So he starts to decelerate. Then again, his speed is decreasing. So again, he will reach balanced force. So here another terminal velocity is reached. So then finally he lands. Okay. So as this video is only about the past paper, I'm just giving a review. So this is just a revision. If you need video based on this one, you can mention it in the comments. I will upload another video based on the content, okay? The motion content, okay, all the content. So this is just a review. Okay, so we know this already. So based on your understanding, I'm just rushing, just revision. Okay. Now, they have added a new earlier in the old syllabus, we only have up to this, only for the parachutists. Now they have also included for objects falling into a liquid. Okay, so if it is from a liquid, so if you're going to do an experiment based on, like, you take a castor oil or something and you're going to drop some sphere, okay, then you will get a curve like this. Because, so say for example, you're going to drop it from here. So already the object is moving with certain velocity u, then it is going to reach here, then it is going to move into due to viscous force, the speed of the object is going to decrease. So this will be the curve. Finally, it will also reach a terminal velocity inside then it is going to reach a steady speed. Actually, it will be like this, okay, when it reaches a steady speed. But this is how it experiences, because it is already having some initial velocity. Then due to the drag force, its speed decreases. And at one point, again, this will be like this. Inside, if the column is very long, then the sphere or whatever you're dropping inside will gain terminal velocity. Finally, the speed will go steady. Okay, it's a horizontal line after that. Now, if it is falling into a river or ocean, okay, at a greater height, say for example, some asteroid or something is falling into the ocean, then in that case, so when it is entering the Earth's atmosphere, it's going to have, it's freely falling for a few seconds. After that, due to air resistance, so it starts to decelerate. Then because it is decelerating, air resistance also decreases. Okay, whenever something decelerates, air resistance also decreases. When air resistance decreases, at one point, it reaches terminal velocity. Then it is now going to drop into the, it has now reached the water. So at this point, okay, at this point, now it has reached the water. Say, for example, here, it reached the water, then it started to decrease. Here, it reached the water, then it is decreasing, its acceleration is decreasing, and finally reaches terminal velocity as same like this. So you bring this curve here. Okay, up to this, then here it reaches the water, here. So from there, then it goes like this. Okay, so this is for liquid. Okay, getting into the question. A student measures the average speed of a cyclist in a race. Which quantities must she measure? So she's going to measure the average speed. You remember the formula for average speed? It is total distance divided by total time. So what are the things she needs? So it's C, yes or no? The total time taken to complete the race and the total distance. Yeah, so these two things. It's not A, and then the time taken. No. Only the time taken is measured. So it's C. The time taken to reach the highest speed and the total distance traveled by the cyclist. It is not only, we are not only measuring the highest speed. Okay, when it is average, because it's an average speed, we also measure whether it is high speed or low speed. We measure everything. Starting from the journey started to the end of the journey, we will measure all the values of the speed. So that's why we say total distance divided by total time. Okay. Which statement about acceleration is correct? You remember acceleration? Acceleration is change in velocity by time. So which one gives the definition? Related to changing speed. Okay, change in velocity by time. So changing speed of an object. So it's A. The diagram shows a series of images of a moving object taken at regular intervals. The object is moving from left to right. So it's going like this, from left to right. So here, which statement describes the motion of the object? And it is moving at regular intervals. That means these dots are taken at regular intervals. Let us say 1 second, 1 second. So 1 second, the next second, okay, the next 1 second, I put 2 seconds, okay, starting from here, okay. The third second, the fourth second, the fifth second, like that. And you see the sixth second, the distance is getting increased. Then 7, it is increasing more. 8, it is increasing more. So how can we conclude? It is not accelerating. It is not decelerating. The object travels at constant speed and then accelerate. The object travels at constant, then decelerate. No, it is not decelerating because you can see it is covering a longer distance. Okay, it is covering a longer distance as it goes. So it is accelerating. Okay, then the next one is an athlete runs 2.4 kilometer in 12 minutes. What is the average speed of the athlete? Be careful with this type of question. Here it is in kilometer, here it is in minutes, and here if you see all the options are given in meter per second. So here, first of all, you convert this to the distance to meter, which will be 2,400 meter, because this times 1,000, 2.4 kilometer times 1,000 is going to give you 2,400 meter. Then that is the distance, and 12 minutes is going to be 12 times 60 seconds. So average speed is going to be, average speed. Okay, it's going to be 2,400 divided by 12 times 60. So which would be the right option? It's B. Am I right? Okay. The next question. Okay. 4 objects are moving in a straight line. The table shows the distances moved by each object in each second of its motion. Which object is moving with constant non-zero acceleration? Constant, that means this, it should cover increasing distance. Okay, so the acceleration shouldn't be 0. That means it is positive. So it should cover more distances as it goes. And which one is that one? Which table is moving with constant non-zero? Constant. Here it is covering the same distance. So it's not this one. How about this one? 1 meter, another 1 meter, another 1 meter. So the acceleration also will be constant. Okay, because it is covering equal distance, like change in distance. The change in distance covered here is 1 meter, 1 meter, 1 meter for every second. So it's how about here? It's 5 to 7 increasing, but then it is 3. Here it is 2 meter, here it is 3 meter. It's not constant. Okay, so here the distance covered is like constant here in B. Option B is constant. So we get a constant positive acceleration. Okay, we want a constant positive acceleration. So it is B. Okay. The next one, an aircraft is moving at 60 meters per second in the north direction. It's like this. Okay, this is direction. Then there's a wind from the east, from the east. So it's going to be like this towards the, yes or no? I'm sorry. So it's going to be like this. Let me. Like this. Okay, 90 degree. From the east. Okay, so like this. So how, for this type of vectors, how do we find? You can complete the rectangle. Then you can draw a resultant, because this is the starting point of the aircraft. So its velocity is in the north direction, and it is also experiencing another velocity, another vector in the towards the left. That means from east to west. So how do we, this type of question is very easy, like 60 meters per second, and this is the wind is 13 meters per second. So we find the resultant R, this is R. R is equal to square root of 60 square plus 13 square. What would be the answer? 60 square plus 13 square. 61.3 something. So it's C. Yeah. So, okay. The next question. A car joins a road at a speed of 14 meters per second. So we keep that as U. Okay. And accelerates at 4 meters per second. So this is acceleration and time is given. What is the final speed of the car? So we want what is V. So we can use, because acceleration is given, initial velocity given, time is given, we can use the formula for acceleration, which is V minus U divided by T, which is going to be V. I do not know V. So I'm going to substitute all the other values. So A is going to be 4 meters per second square, which is equal to V minus U is 14 meters per second divided by 5 seconds. Okay. So let me just do without the unit. 4 times 5 is equal to V minus 14. So this is going to be 20. Then this 14 is going to come on this side as plus 14. That will be your V, which is 34. 34 meters per second. Yeah. So it's D. Okay. The next one. A man stands next to a railway track. A train traveling at 40 meters per second. This question is being repeated so many times, even from the beginning, from the early years, like 2004, 5, 6, something like that. Yeah, I have seen this question even in old papers. So this is the speed given and time is given. What is the length of the track? Okay, so it starts, suppose if this is going to be the starting point, and when it starting from that point, when it when it is reaching this man's position over here, from that, it is counted that it takes 2 seconds to reach this point. Okay, 2 seconds. So what is the length of the train? So it's going to be like speed is equal to distance by time, and we want the distance covered by the train. So it's going to be like speed times time. So it's 40 times 2, which is 80. Okay. Okay. The next one. A car starts from rest. The table shows the readings from its speedometer every 10 seconds. Which motion describes the car's motion in the first 30 seconds and in the last 30 seconds? So how it is moving in the first 30 seconds? Speed is like increasing. It is increasing, constant. 12, 12, 12, maintaining constant. Yeah. So here you can say that it's constant. This is also constant. So here, which one? Constant speed, zero. No. Non-zero acceleration, this cannot, it is not at rest. It is continuing with the same speed, 12 meter per second. So it is constant speed. So there are only two constant speed. Definitely it is not zero acceleration initially. So here it's constant speed and non-zero acceleration. Okay. The next one. A plane flies from town X to town Z. Okay. So actually it's going from here to here. Actually, the displacement is here, like something like that. Okay. But stopping for 1 hour to town Y to pick up more passengers. Okay, so instead of going directly, it has to go through another town. It is flying through 300 kilometer to reach Y. Then it picks up some passengers, then comes back to comes to Z, which is at 200 kilometer. Okay, the total time taken between leaving X and arriving Z is, this is the total time. So this is the total time. What is the average speed of the plane in the air? Very important, because average speed is given as total distance divided by total time, But here we cannot take the total time as 3 hours. This is a total time. We cannot take this as total the 3 hours here in this question, because they only want the average speed of the plane in the air. Okay, so in that case, look, it took 1 hour to stop. So now out of 3 hours, 3 minus 1, it's going to be 2 hours. So the time taken by the plane to fly from X to Y and Y to Z is totally 2 hours. That's it. So the total distance covered is 300 plus 200, which is 500. Okay, 300 plus 200, which will be 500, divided by only 2 hours. 2 hours. Okay, 500 kilometer divided by 2 hours. So it's going to be C. Okay. Then the next one. A cyclist rides 300 meter up a slope in 50 seconds. Then she rides down the slope. She's going up and then she's coming down in 25 seconds. Yeah, because she's sliding faster. Okay. What is her average speed for the whole journey? So we know again, average speed is total distance. What is the total distance? She's going 300 meter, again coming back 300 meter, but only one 300 meters shown. So you have to be careful. So 300 plus 300 is the total distance. So total distance is 600 meter divided by the total time is 50 plus 25. So it's 600 divided by 75. So the answer would be that 8. Let's see. Yeah, please check. Okay. The next one. So how do you do this one? This is a velocity time graph. Speed time graph, velocity time graph, more or less the same, except in velocity, you will have some like a negative velocity on the, we are not dealing that one, but velocity time graph is similar to speed time graph. Okay. Here, the diagram shows the velocity time graph for, okay, which is accelerating. What is acceleration of the object? So we know acceleration is final velocity minus initial velocity divided by time. What is the final velocity? 120. What is the initial velocity? 20. And the total time taken to make this change is 40 seconds. Yeah, you can take from here, from the graph, 40. Okay, so it's going to be like 100 divided by 40, which will be 2.5. Yes or no? Yeah, 2.5. Okay. Okay. Then the next one. The motion of an object is represented by the speed time graph. Which quantity is equal to the area under the graph? We know area under the graph gives you the distance traveled. Area under the graph gives you the distance traveled. So it's C. The next one, the graph shows how the speed of an object varies with time. Which row describes the motion of the object at times P and Q? speed time graph. When you see like this, you can interpret, see speed and time. It is moving for this much time. It is moving with the same speed. So constant speed. So here it is steady speed, steady. And how about Q? It is moving from 0 to some value. That means speed is increasing. Whenever speed is increasing, it is accelerating. Acceleration. Okay. Steady speed. And this is acceleration. So P is steady, yeah, constant. It's accelerating. So it is C. Okay. The next one. The graph shows how the speed of a car changes during a period of 50 seconds. Which row gives the car's greatest acceleration and the car's greatest deceleration? Acceleration means increasing speed, deceleration, decreasing speed. Which one will be the greatest acceleration and greatest deceleration? 0.75 and 1. No. Okay. Changes during a period of 50 seconds. Okay. Which row gives the car's greatest acceleration and the car's greatest deceleration? So actually, I think it must be here. Can you see here? And the greatest acceleration is where the speed is increasing. Let us check this one. Let us check this gradient. Gradient. Okay. Gradient is 20 divided by 15. Actually, it is 20 minus 0. 15 minus 0. That is the answer. So 20 divided by 15 is at 1.3. 20 divided by 15. Yeah, 1.3. Okay. So this is 1. And greatest deceleration, I think this one. Okay. So this one and this one, greatest deceleration. Let us check. So it is 15. The change in velocity. Wait. This is u actually. This is u. 15 is equal to u. And the final velocity here is 0. So 0 is equal to v. So how do you make the gradient? V minus u is 0 minus 15 divided by, what is the time? Like 50 minus 45. Okay, 50 minus 45 is 5 seconds. So here it is minus 15 divided by 5 seconds, which will be minus 3 meter per second square. Minus 3. The negative is it indicates the negative acceleration, which means deceleration. So here the deceleration, which is negative acceleration, is 3, and so it's D. Okay. The diagram shows how the speed time graph for a car. Sorry. The diagram shows the speed time graph for a car. Which row describes the motion of the car at point X and point Y? Okay. At point X, speed is changing from 0 to some value. That means acceleration. And from this time to this time, the speed is maintained the same speed. So constant speed. So acceleration and constant speed. Constant speed. So here it is not rest. This one. Changing speed. Of course, it is changing speed and moving with constant speed. D. Yeah? Okay. The graph represents the motion of a vehicle. What is the distance traveled by the vehicle in 400 seconds? Whenever you want to find the distance traveled, you have, for speed time graph, you have to go for area under the curve. Area under the curve. So here it's a straight line. So the area under the curve is going to be a triangle. Don't get fooled by this rectangle. Okay. So this is actually 20. So here half base times height, area of a triangle. Okay. That is the area of the triangle. A is equal to. So half times base is 400 times height is 20. Because this looks like a rectangle, students go for like 20 times 400. Don't do that one. So the area under the curve is going to be a triangle. Okay. So it's like 200 times 20 is going to be 400. No. I mean, 200 seconds, 400. So it's 200 times 20. 4,000. Yeah, 4,000. It's not 400, 4,000 meters. So it is C. Okay, the next one. Please wait. Just give me a minute. Okay. The next one. The graph represents the motion of a car. How far has the car moved between 0 to 5 seconds? Okay. How far? Again, distance travel. Okay. Distance travel is area under the curve, which is going to be like half times base is 5. The height is 10. So it's like 25. Yeah. It's 25. Okay. The next one. The speed time graph shows the motion of an object. How far does the object travel at constant speed? Only for constant speed. So no need to worry about that. So for constant speed, can you see here between 5 to 15, it is having the same speed of 5. So only the area under this rectangle, okay, this section, only this you have to find. So this is length times breadth, which is 10, because 15 minus 5. 15 minus 5 is going to give you 10. So it is 10 times 5, which is going to be 50 meter. Yeah, so it's 50 meter. Okay, that's it. Okay, the graph shows the speed of a car traveling through a town. Which section of the graph represents the period when the car is decelerating? Decelerating means negative acceleration. So where its speed is decreasing. Speed is decreasing from here, from a certain value, from a positive value, it is going to go to 0. So at D. Yeah. Okay, the next one. A train is on a straight track. The graph shows how a quantity Y varies with time. Okay, which statement can be true? So they didn't give, the time is given. This graph shows how a quantity Y. So we have to find what is that Y. Okay, let us say. For a distance time graph, if it is like this, it is stopped. For a speed time graph, if you have a line like this, then it is steady speed. Let us see what statement matches with this one. The train is stationary and Y represents the distance from the last station. Yes, I agree. Then the train is moving and Y represents the distance from, of course it is not moving. It's not moving. It's not moving. The train is stationary and Y represents, no, this is also, it doesn't represent the speed of the train. Because if it is stationary, for speed time graph, speed time graph, and it is stationary, it will be like 0. Okay, speed is 0. So, but here it is having some positive value, so it can't be 3. The train is moving and Y represents the speed of the train. It is stationary and Y represents the speed of the train. Okay, it can be steady speed, yeah. The train is moving and Y represents the speed, yeah, steady speed. So it's 1 and 4. It could be the train is stationary and Y represents the distance. So it could be this is also correct. Or the train is moving. If you take Y as a speed, the train is moving. It is moving with a constant speed. They didn't mention that. And Y represents the speed of the train, of course, correct. So 1 and 4. Statement 1, 3 is wrong, and 1 and 4. So it's B. Clear? Okay. The diagram shows a speed time graph for a moving object. Which description of the object's motion is correct? Obviously, whenever you see a curve like this, its gradient is decreasing. Yes or no? Its gradient, it's getting a decreasing gradient. So the gradient is decreasing. So it decelerates, or decreasing speed? Decreasing speed. No, this is already, sorry, this is already speed time graph. So decreasing acceleration. So the gradient gives you the acceleration. So decreasing acceleration. Yeah. Yeah. Okay. So decreasing speed, so which gives you the acceleration. The gradient is going to give you the acceleration. So decreasing acceleration. A speed time graph is used to describe the motion of an object. Which quantities are calculated from the gradient of the graph and from the area under the graph? Oh, that's easy. What is going to give you the gradient under the speed time graph? The gradient is going to give you acceleration. And from the area, we are going to see the distance traveled. Okay. So which one is giving? It's A. Okay. So it's A. Okay. Now this one. The diagram shows speed time graphs for 4 different bodies moving for 6 seconds. Which body traveled the least distance? So you can find the area under the graph. Instead of going one by one, we can just roughly estimate. Like if you see here, okay, let us count the one full square box. 1, 2, 2.5, 3.5. Like I keep this as 4.4. Okay, this 4, 5, like around only 5 boxes. How about here? One full box. This is I'm talking about one full box. 1, 2. Shall we put this as half? 2, 2.5. Then another half here. 3. It's like between 4 to 5. Okay, this is between 5 to 6. Let us keep this one 5 to 6 boxes, 4 to 5 boxes. And this one, definitely not this one, because this covering, like you have to find the area of the whole, like 8 times 6. So, and this one also, only 2 boxes are left. So not C and not D. The least distance is traveled by object B. Okay, so only here the area under the curve is less, only 4 to 5. This is 5 to 6. So it's B. Okay, so the next one. The velocity time graph of a car is shown. What is the distance traveled by the car in 35 seconds? Okay, so that means, look, you have to find, you can split this region like the first one is a triangle, the next one is a rectangle, the last one is a trapezium. If you still want to split this trapezium, if you have forgotten the formula for trapezium, you can still split this into a triangle and then the rectangle also. So here I'm just going with a 1, 2, 3 sections. For section 1, the area under the curve, it is a triangle, so it's going to be half times 10 base. The base is 10, so 10 times, and the height here is 10. So it's going to be 50. Second one, it's a rectangle. So it's length times breadth, which is going to be, the length is going to be 25 minus 10. 25 minus 10 times, what is the height? The breadth is going to be 10. 10 minus 0. 10 minus 0. So I'll be getting like 15 times 10, which is going to be 150 meter. For the third one, for trapezium, the formula for trapezium is half times HA plus B, where the H is the perpendicular distance. So wow, I can take, I'm going to take like this. So the graph is like this. A, B, and H, because the perpendicular distance, okay, the 90 degrees, for the perpendicular distance that is joining A and B. So here, A is going to be 10. This is 10. B is going to be 20. And the H is going to be 35 minus 25, which is going to be 10. Okay, so that's it. So half times the H is 10. A plus B is 10 plus 20. So which will be 150 again, right? 2, 5, 30, 150. Yes, yeah, 150. So you add all now, 1 plus 2 plus 3, all the areas are added. So you get 50 plus 150 plus 150, 300, 350. So it's 350. Yeah. This is 350 meter. So answer is B. Which statement about a falling object accelerating close to the Earth's surface is correct? Close to the Earth's surface. Okay, the object is accelerating and it is close to the Earth's surface. So which one will be the right option? The weight of the object is increasing. No. The weight of the object and the force of the air resistance on the object are of equal magnitude. No, we can't. Nothing about terminal velocity or steady speed, nothing is mentioned. And they say it is accelerating. Okay. When it is accelerating, that means definitely there is an unbalanced force. So definitely when it is something is accelerating, there is an unbalanced force. So we cannot say that it is of equal magnitude. And the weight of the object is constant, of course, but the force of air resistance on the object is increasing. Okay. Yes, this could be true. The weight of the object is less than the force of air resistance. No, not this one. Depending upon the weight, the air resistance also will be like, high or low. So just because it is less than the force of air resistance. No. Okay. So this one is the right option. The weight of the object is constant, but the force of air resistance on the object is increasing. So there is an unbalanced force. So there is unbalanced force. So F net is positive or negative. So based on that, it is accelerating. Okay. A ball falls from rest through the air towards the ground. The diagram shows two forces acting on the ball. So did I finish that? Wait, one second. Yeah. So as the ball falls, the air resistance increases. Which statement is correct? As the ball falls, the air resistance, when air resistance is increasing, so what happens? Like the weight is not going to change. This is constant. So if the air resistance is increasing, that means it is increasing. So what happens? This is air resistance. I put F air. So the F net is going to be F air minus W. So this value, F net, is going to decrease. It's decreasing. Okay, it decreases. When F net decreases, F is equal to mass times acceleration. So when F is decreasing, A also decreases. So which statement is correct? The acceleration of the ball decreases. No, it will not increase. Okay. The speed of the ball decreases. Acceleration decreases. That is the correct statement. Yes or no? Yeah, because there is a resultant force. So rather than mentioning speed or something, so acceleration decreases. No. Okay. Let's see. A light ball is held at rest at the top of a tall cliff. It is released and falls through the air eventually. Which road describes the behavior of the ball as it descends? Okay. So it's coming from a top cliff. Okay, from that point, it is going to come down from a... So at this point, once it leaves the cliff, the only force acting on it is the gravity, 9.81 meter per second square. Then eventually it reaches terminal velocity. So in between, it is going to reach terminal velocity. So the ball here may be reaching terminal velocity, means constant speed. Constant speed means no acceleration. Constant speed gives you A equal to 0 meter per second square. So which one is correct? So 9.81. They didn't give the value, but it is G. Okay, the initial acceleration of the ball is G and 0. G is 0. C. Yeah? Okay. 1 second. Okay. The next one. An object falls towards the surface of the earth. The object is falling at its terminal velocity, A0. Okay, constant speed. Terminal velocity is constant speed, A0. Which statement is correct? So there is air resistance and the acceleration is negative. No. Terminal velocity is constant speed. We cannot say that the acceleration of there is air resistance and the acceleration of the object is 0. Yes, correct. Okay. We cannot say that there is no air resistance because terminal velocity is reached only when the forces, the downward force due to weight and the upward force due to air are balanced. Okay, these two must be balanced. These two must be equal. Only then the terminal velocity is reached. So we cannot say there is no air resistance. So there is air resistance and the acceleration of the object is 0. There is no air resistance is wrong. There is no air resistance. This is also wrong. Okay, the next one. An object reaches terminal velocity after being dropped and falling through air. Which graph shows how its speed varies with time? Okay, so obviously not this one, not pointed edge, not pointed, no, not this one. Like this, look. So up to this few seconds, it will be a straight line, then its acceleration decreases. Okay, then it reaches terminal velocity. So this graph, see. A skydiver jumps from a plane and falls towards the earth. Which statement is correct? When the skydiver has reached the terminal velocity. Terminal velocity, again, A equal to 0. Okay, there is air resistance. Wait, Fa. Okay, then what? The skydiver speed is decreasing? Wrong. The skydiver speed is increasing? No, because terminal velocity is reached. That means constant speed. Then there is no point of decreasing, increasing. Constant speed. That skydiver is moving with constant speed. This is correct. The skydiver's speed is 0. No. No. Okay. So that's it. Thanks for watching. Please like, share, and subscribe. I will see you in the next video. Bye.